Hello everyone, we are Group 14. I'm Zuka Chen. This is our project LinguaMind, a comprehensive software application. In our society, students and teachers work and learn in a fast-paced, high-stress, close-knit environment and are often faced with a variety of tasks and responsibilities related to academic work. This causes forgotten important tasks, time management difficulties, discrete efficiency, communication problems. Next are the methods we identify and gather project requirements. First, we start brainstorming and perform the internal research to create a preliminary requirements list. Then we interviewed stakeholders, talked to multiple people to identify the capabilities and the features. And also we did observation to end users to gain insight into behaviors and performance that we might not get from talking. These are the parent level requirements which would be implemented the large language model of ChatGPT to overcome language barriers, the streamlines communication, manage efficiently schedules.
Hello, my name is Ji Guanlan. In this section, we will focus on the various software design proposals. At the very beginning of the design stage, we proposed three types of potential design. First one is PC client application installed on the user's personal computer. Mobile applications such as Android or iOS app and web application can be accessed through the browser. Each of them has their pros and cons, and we will introduce them in the following part. Starting with the PC client application, its key stress lies in robust performance and responsiveness. It can be used offline, use the systems for capabilities, enhancing the user's experience. However, our project relies on the OpenAI API, means online connectivity is vital. What's more, it can only be used on a computer, which is not convenient enough in some cases. As a result, it is not suitable for our project. Turning to the mobile app, it provides excellent probability and is very good user experience. It can potentially tap into device-specific features. However, in our project, the LLM app will not use any of the functions of the mobile device, so it can't reflect this advantage. Moreover, it will be hard to use on a computer and cannot fit some formal work situations. So it is also not good enough for our project. Concluding with the web app, it is usually accessible on any device with a browser and do not need to installation in advance. It also be easier for our administrator to maintain or update the applications as they only need to update the version of the server side. Also, it is convenient for the developers to develop and deployment. A web application also have disadvantages like it must be online and has performance limitations. But these shortcomings can be ignored in our project because we must be online or to get response for OpenAI API, and we don't require too much resources. To sum up, because of its significant advantages and minor disadvantages, we decided to employ this kind of design for our project.
Hi, I'm Warren Lee. Next, I will talk about our design models. First of all, let's look at the use case diagram. This diagram contains three different actors, which are student, teacher, and system administrator. After sign-up and logging, students and teachers can have access to the system. They can use functions like AI translation, conversation generator, AI article polish, AI schedule planning, and so on. Administrators can perform system maintenance and manage accounts in the backend. Next, let me show you the class diagram of our project. It can be roughly divided into three parts, which are users, the LinguaMind system, and the ChatGPT system. The teacher class and the students class inherit from the user class. The user class contains important attributes and methods for user login and their personal profile. For the LinguaMind system class, it contains some methods for user interaction and the message transformation. Basically, for every user's API request, it will be sent to the LinguaMind first, perform some pre-processing, and then be sent to ChatGPT. The results will follow the same way back to the user. The object diagram is drawn based on the class diagram. It provides object instances, the associations between objects and their attributes. There are altogether 4 objects, instances of 3 user groups, and 1 instance related to the system itself. Each object has its own distinctive attributes. These 4 objects will have interactions between each other, same as the class diagram.
One excursion. Now the activity diagram usually presents a series of actions in the system, while the interaction diagram visualizes the interaction behavior of the system. Activity diagram, we use the swimline to represent the actor, while the interaction diagram, we use the lifeline to represent the actors. In the activity diagram, we use the actions as well as 4 other functionalities, relations like the join, merge, fork, as well as the decisions, while the interaction diagram, we utilize the message as well as the reply message. Machine diagram represents the behavior of a single object, specifying the sequence of the events that objects. So in this diagram, we utilize the pages as well as the message to represent the states of the objects. So in a page, it contains the codes, messages, as well as the data. Okay, let's pass to the Zhang Duo.
Hello, this is Duo Zhang, and for our component diagram, both of the users and admin need to log in to verify their identity. Users need to access the database through the system, but admin can directly access the database, and then they can send the SQL statement to our database. For the deployment diagram, users can use PCs and web to log into the system, but the admin only can use the web browser. Our system contains the web server, application server, database server, PC, and CRM views. For the change management, there are 5 parts: requirements, control, collections. We gather feedback and suggestions from all our stakeholders, which are the teachers and students. Change assessment: upon the receiving any change requests, our team evaluates its impact on the system, considering the technical risks, costs, and timing, decision making, and communication. We then decide whether to accept these changes. Every decision is communicated with all stakeholders, ensuring transparency in implementation and testing. Once a change is approved, our development team can get to work. Every change is rigorously tested to ensure it doesn't negatively impact existing functionality. Documentation and checking: we document all changes and use a version control system to check every single modification. Thank you.